Number 6 reads, a tennis ball is struck such that it leaves the racket horizontally with a speed of 30 meters per second. That's your velocity in which direction? If it's a horizontal speed, that's your velocity in the x direction, right? The ball hits the court at a horizontal distance of 20.6 meters from the racket. So that's your delta what? If it's a horizontal distance. That's your delta x, right? And the question is, what is the height of the tennis ball when it leaves the racket? So what's another way to say height? That's your delta y, right? Okay? So you see how half the problem is just reading it carefully so that we can identify all the variables. Okay? So let's go ahead and set up this problem so we can visualize it, label all the info on our pictures, and then break it all down. Step 1, we make a little sketch. Okay? In tennis, the goal is to hit the tennis ball. Ooh, as you can tell, I'm not a very good artist, okay? Across the net, such that you don't miss, and then your opponent will miss, right? Okay, so whatever. We're hitting a tennis ball, boom. There's my tennis ball. And it's flying across the net, okay? And the key thing is we're only hitting it straight sideways here for now. No angle. Velocity in the x, okay? And it's hitting somewhere out here, whatever, boom. Numbers were given as what? 30 meters per second is our horizontal speed. And we also know the what? Horizontal distance of 20.6 meters. So we got 20.6 meters from here to here is our delta x. And what we're trying to solve for is the height from which the tennis ball was launched from the racket. Okay? So a little sports physics here for you. So now in step 2, it's easy to separate out the information in 2 columns because we broke it down on our diagram. We got delta x is given as 20.6 meters. We don't velocity x we do know as 30 meters per second. Time we can solve for in a second when we need it. In the vertical direction, there are 5 knowns and unknowns: vi, vf, a, delta y, and time. Delta y we know, or we don't know. That's what we're trying to solve for in meters. Okay. Acceleration due to gravity is negative 9.8 meters per second squared. And now we have to read into the hidden info. Which is the one that we can read into? Do we know vi or vf? Which one do we know? We know vi. That's correct. Vi is what in this case? 0 meters per second. Okay. Because the ball isn't hit up or down. It's just hit straight sideways. So at the very start, the initial vertical velocity is 0. Okay, so it's not to say the speed is 0. It's just the vertical speed is 0. Okay? So in order to solve the delta y, we need one more piece of information. We only have 2 here, right? We only have acceleration, and we only have vi. So we need one more. And the one more we can get, that's correct, is time by going to the horizontal info. Okay? So this one's just a little bit different, because normally we do vertical first and then horizontal. But in this case, you have to do the horizontal info. Horizontally, we only have one equation, right? In our nifty equations, we just have our delta x equals vx times time. Old-fashioned distance equals rate times time. When we shove in our numbers here, delta x was 20.6 meters. The speed of the tennis ball was 30 meters. We're going to solve for time. So time is just 20.6 over 30. So if I get out my calculator, I can plug and chug really quick here. I just take my distance of 20.6 meters divided by 30 meters per second. I'll get across the court in 0.687 seconds. And now we can find our delta y because we have time, okay? So you tell me which would be a good equation to use if I know time, I know acceleration, and I know vi, but I don't know vf. Again, which equation is perfect? If you don't know vf, only one equation doesn't have vf. Right? That's equation number 3. Yeah, the Galileo one. We're going to use delta y equals vit plus 1/2 at squared. Delta y is our unknown. Initial velocity is 0 vertically. 1/2 acceleration is negative 9.8 times the time squared of 0.687. Okay? So when I get out my calculator, I'm just going to plug and chug 1/2 times negative 9.8 times my time of 0.687 squared, I get negative 2.31 meters as my final answer, but we have to make sure we answer what the question asks. It just asks, what is a height? Okay, so if it's just the height, if the tennis ball fell negative 2.31 meters, then it leaves at a height of positive 2.31. It didn't ask for the displacement. Okay, so again, just answer what the question asks, and you don't have to worry about is it positive or negative. You don't memorize. Okay, positive just means it's an up direction. Negative means it's a down. But this one's not asking for displacement. It just says what's the height. In a nutshell, that's